Okay, so let's get started. The agenda for today's session is just statistical inference. I have two notebooks over here, and then I have a set of quick practice questions on some important concepts in statistical inference. तो पहले हम इनमें से कुछ चीज़ों को reiterate भी कर लेंगे. Starting with the law of averages. For the law of averages, we have a famous problem, the Monty Hall problem. This was already covered in class. I'm just quickly going to run you through this visualization to show you how this works. Even before we look at the Monty Hall problem, let's recall what the law of averages is. So the law of averages refers to, and it only applies to chance experiments. So it says that if a chance experiment is repeated many times independently and under the same conditions, then आप उसको जितने times repeat करेंगे, the proportion of times that the event occurs will get closer to the theoretical probability of the event. For instance, if you toss a coin, the probability of getting heads is equal to 50%. But if you toss a coin 10 times, so it's possible कि 9 out of 10 times head आ जाए. But that doesn't mean कि उसके head आने की possibility ही 90% थी. However, the law of averages, under the law of averages, if you toss it like 10,000 times, so फिर the number of times that you get head for will get closer and closer to 50%. It will be closer to 5,000. It's highly unlikely कि उन 10,000 में से 9,000 times head आए. With that, let's recall the Monty Hall problem really quick. So, this is based on an American television game. You are given three doors, and between one of the three doors, there is a car. Between the other two doors, there are goats. You're supposed to pick one. The host knows कि किस door के पीछे car है. So, either you're gonna pick a door with the car behind it, or you're gonna pick a door with the goat behind it. Either way, without opening the door that you have picked, the host will open one of the two remaining doors. The thing is though that the host will definitely open a door जिसके पीछे goat है. After that, two doors remain closed. There is this one door जो आपने select किया था, and then there is this other door जो host ने नहीं open किया. So the host will give you a choice. Either you stick with the door that you picked initially or you switch the door. And the question is switching your doors going to increase the probability of you winning? The answer is that it does improve the probability of you winning, because under standard probability की assumptions, जब आपने एक डोर पिक किया तो उस डोर के पीछे कार होने की probability was 1/3. जो रिमेनिंग टू डोर्स थे उनके पीछे कार होने की प्रोबेबिलिटी वन ऑफ द टू डोर्स was 2/3. सो उन टू में से होस्ट ने जब एक ओपन कर दिया जिसके पीछे कार नहीं थी, तो दैट मीन्स दैट द डोर दैट द होस्ट didn't open has a total probability of 2/3 of having the car behind it, which means that switching your door is going to double your chances of winning. I hope that this makes sense. Are there any questions? The thing,
Shiza,
yeah,
I do have a query here.
yeah, go on.
Once the door is opened, why is our sample space still three? Why is it not two?
Oh no, sample space हमारी इफेक्ट नहीं हुई. The thing is कि जब आपने initially, let me just show you over here as well. So initially आपके पास three doors थे. हर door के पीछे car होने की probability was equal. It was 1/3, right? Just copy this value. Suppose कि this is the door that you had selected, okay? Which means कि remaining two doors के पीछे car होने की probability was equal to 2/3. अब ये 2/3 का number fixed है because this is a percentage. There is a 33% chance that the car is behind the door that you picked, and there is a 67% chance that the car is behind one of these two doors. अगर इन दोनों डोर्स में से एक डोर ओपन कर दिया होस्ट ने एंड उसके पीछे कार नहीं थी, सपोज इट वाज दिस डोर, तो उसके पीछे कार होने की प्रोबेबिलिटी अब जीरो हो गई। यू नो दिस इंफॉर्मेशन बिकॉज उसके पीछे कार नहीं है, विच मीन्स कि जो रिमेनिंग डोर था उसके साथ ये प्रोबेबिलिटी एसोसिएटेड है। डज दैट मेक सेंस?
Yes.
ओके, ऑल राइट। सो द थिंग इज दो कि अगर आपने 100 गेम्स प्ले की हैं और सपोज कि आपने सिर्फ 10 गेम्स प्ले की हैं, तो थियोरेटिकली if you switch the door, तो in about 6 to 7 out of those 10 games you should win. But this may or may not be true. You may win in all of them, or you may not win in any one of them, because 10 is a very small number of games. But if you play the game 1,000 times, then you're very likely to win in about 670 of those games. Which is why we have this simulation over here. The code is not for you to be concerned about at all. सिर्फ हम उसी गेम को सिम्युलेट कर रहे हैं, एंड यू हैव एन इंटरैक्टिव प्लॉट दैट इज गिवन टू यू, जिसमें आप नंबर ऑफ ट्रायल्स को सेट कर सकते हैं. सो सपोज दैट दिस इज व्हाट आई डिड. आई सेट द नंबर ऑफ ट्रायल्स टू 10. सो मेरे पास एक्स एक्सिस पे नंबर ऑफ ट्रायल्स हैं एंड वाई एक्सिस पे आई हैव द प्रोबेबिलिटी ऑफ विनिंग. You see कि as I am increasing the number of trials, ये जो dotted line से marked है, this is the theoretical probability. So, the blue line indicates a switching strategy. For switching, the theoretical probability of winning is around 0.67. For staying with the same choice of door, the theoretical probability of winning is about 33%. बट जो मैं probabilities calculate कर रही हूँ given the number of trials that I'm running, they are still deviating from my theoretical probabilities. When I increase the number of trials and suppose कि मैं number of trials को ले जाती हूँ about 3,100 तक, तो now you will see कि I have actually gotten really really close to the theoretical probabilities now. अगर मैं इसको और इंक्रीज करूं तो इट विल फील लाइक आई एम एग्जैक्टली एट द राइट थियोरेटिकल प्रोबेबिलिटी. आर देयर एनी क्वेश्चन सो फार? Okay, well, we're going to move on towards hypothesis testing then. I'm going to reiterate the number of steps over here as well, using an example that you've already covered in class. And well, we're going to look at the same example in code then. Hopefully, we will be able to reiterate most concepts in um, hypothesis testing before we move on to a few practice questions. So let's quickly recall कि ये model कौन सा था. So we're gonna work with Mendel's model of pea flowers. Mendel was an Austrian monk who is widely recognized as the father of modern field of genetics. He was performing large-scale experiments to come up with the fundamental law of genetics. Mendel का experiment क्या था and Mendel का model क्या था? So Mendel's model was that there were different varieties of pea flowers. Either pea flowers were going to be purple in color or they were going to be white in color. So Mendel का model ये assume कर रहा था कि regardless of anything else, regardless of any other conditions, when you plant a flower, there is a 75% chance that it's going to turn out to have purple flowers, and there's a 25% chance that it's going to turn out to have white flowers. ठीक है, ये मेंडल का मॉडल है. Now you want to assess this model, and how you assess a model, इसके लिए हम steps देख लेते हैं. The very first step is that you come up with a statistic that helps you decide whether your data supports the model or an alternative view of the world. So it means कि मैं एक test statistic को select करूंगी which will either favor my model or it will be against my model. This statistic is going to help me take my decision, which means that this statistic has to be relevant for me. आप यूजुअली एक हाइपोथेसिस ड्रॉ करते हैं. देयर इज द नल हाइपोथेसिस which in experiments would assume would assume no effect. Null by default assumes no effect. In this case, it assumes that the model's assumption are true. The alternative assumes an alternative view of the world. So in an experiment, etc., it would assume that there is an effect. जैसे for instance, मैं एक drug का effect measure कर रही हूँ on a patient. So my null hypothesis would be that this drug does not impact recovery. And my alternative hypothesis could be that this drug does impact recovery or that it increases the chances of recovery, however you state it. In this case, my null hypothesis is that my data is coming from the model, and alternatively, the data is not coming from the model. So this is what we're trying to understand. The statistic that you come up with helps you decide कि वो null को support कर रहा है आपका data या नहीं कर रहा. So anyway, this is how you come up with a statistic. Just give me a second. Yeah, here we go. So, when you're selecting a statistic, you want to ensure पहले आप ये देखते हैं कि कौन सी values हैं इस statistic की, and there are several valid statistics for the same scenario. We have accepted several in the past in exams as well. So first you see कि कौन सी values हैं इस statistic की that will make you lean towards the null hypothesis, and what values are going to make you lean towards the alternative. Your answer should actually be just high for the alternative. जितनी statistic की value low है उतना आप null की तरफ incline करेंगे, and जितनी statistic की value high है उतना आप alternative की तरफ incline करेंगे. Once we choose a statistic, well, before we actually look at the next step, let me show you the statistic that we are choosing over here without reading the rest of the scenario given. So आपने जो statistic लिया है, that is the absolute value of the difference between the proportion of purple flowering plants and 0.75. Why? Because 0.75 was the probability as per Mendel's model of well, purple flowering plants. It means कि अगर 1,000 plants आपने grow किए, तो according to Mendel's model, according to the null, 75% of them should have been purple. इसीलिए जो actual proportion आता है purple flowering plants का, अगर हम उसका absolute difference ले लें 75 से, तो उसकी वैल्यू जितनी क्लोजर टू जीरो आएगी, जितनी छोटी आएगी, उतना वो मेंडल के मॉडल को फेवर कर रहा है. और जितना ज्यादा इनके बीच में डिस्टेंस आएगा, जितनी बड़ी वैल्यू आएगी, उतना हम मॉडल के अगेंस्ट हैं, we're inclining towards the alternative. Hence we have selected this statistic. Are there any questions so far? Okay, all right. So once you select a test statistic, you simulate the statistic under the assumptions of the model. This means that you're going to generate lots of data for the statistic. And we have seen data generating algorithms in the past as well. तो इसका तो data generating algorithm भी बहुत simple है. आप हर iteration के ऊपर इस test statistic को compute करते हैं, and then you can plot a histogram. So I can quickly show you the code as well so that you know what is happening. At the same time, the code is nothing that you are supposed to remember. So I have an array over here जिसमें मैंने 3 times purple store किया है, and then once I have stored white. This is a function that just computes my test statistic and returns it. So मैं क्या करती हूँ, मैं इसको एक sample pass कर रही हूँ. उस sample में I just count the number of zeros, and then I divide that by the sorry, I count the number of non-zeros where the sample is purple. So I'm just counting the number of times that purple appears in my sample, and I divide that with the length of the sample. इससे purple की proportion निकल रही है, then I return the absolute difference of that and 0.75. We can ignore this for now. I will circle back to this. So anyway, ये आपने test statistic define किया. We're gonna move on from this. Now I am defining a certain number of repetitions. If I've specified 10,000, इसका मतलब है कि I want to generate 10,000 samples, जहाँ हर sample के अंदर I'm gonna have a certain number of total plants. So what happened was कि in actual life जो मेंडल ने grow किए वो 929 plants थे. He grew 929 plants, and the statistic that he observed came out to be this much. See, it's actually very close to zero. We're gonna circle back to the observed statistic. For now, since उसने 929 plants grow किए, so हमने repetitions 10,000 लिए, एंड हर सिंगल रेपिटिशन के अंदर हम 929 प्लांट्स की रैंडम वैल्यूज जनरेट करते हैं फ्रॉम पर्पल एंड वाइट, एंड देन फॉर एवरी सिंगल सैंपल वी कंप्यूट द स्टेटिस्टिक, और उस स्टेटिस्टिक को हम स्टोर कर लेते हैं अपनी एरे के अंदर, सैम्पल स्टैट्स के अंदर. सो दिस इज व्हाट we're doing. Each sample contains 929 plants. हर सैंपल के लिए मैं अपना टेस्ट स्टेटिस्टिक कंप्यूट करूंगी. हर सैंपल जनरेटेड है रैंडमली based on this proportion, because I'm trying to generate data under the null distribution right now, and I do this 10,000 times to get a distribution. सी सो अब मेरे पास ये essentially array आ गई है. इस array की length जो है it's gonna be 10,000, and I have the test statistics against my 10,000 samples in this array. I will convert this into a data frame, and then for my data frame I will, well, मैंने इसको sort किया है and now I'm creating a histogram. So this is how my histogram comes out to be essentially. This is the distribution of my model. इस red line को अभी हम ignore कर सकते हैं, but are there any questions so far?
No, ma'am.
Okay, all right, perfect. So,
I just wanted to
yeah,
ask कि आपने use किए 4 values को array में and then you have mapped those values or that proportion to 10,000 samples
no, I'll tell you what I did. मैंने
because you're
ये फो
using a random generator तो वो तो randomly बना
मैं
देगा ना.
generator use करती हूँ, but I use the generator on the basis of this array. Like I'll tell you what. मैंने ये array define की, और अगर मैं आपको कहूँ कि इन four में से if these four were written on chits of paper and I put them in a hat and I ask you to randomly take one out and read what it says, so what are the chances that it says purple?
Oh, okay.
Three out
3
of
by
four,
4.
right?
Yeah, right.
Yeah,
Okay.
so इस तरह मैं array में से 929 times shit निकाल के वापस डालूंगी. I will sample with replacement. Okay?
Okay, got it.
So उन 929 values के लिए फिर मैं ये function call करके test statistic compute करूंगी. और ये जो पूरा process है, इन 929 values के against मेरे पास एक value आई है test statistic की. फिर मैं इस पूरे प्रोसेस को 10,000 टाइम्स रिपीट करती हूँ टू गेट 10,000 वैल्यूज ऑफ द स्टेटिस्टिक. गॉट इट?
Yeah, got it. Thank you.
Perfect. Okay, are there any other questions? Okay, so one important thing to be mindful of over here is that none of this data was actually real. मैंने उसका मॉडल लिया, मॉडल की assumptions के अंडर I just generated, you can say, synthetic data. None of this data is real, right? Now, in real life, what happened was कि Mendel grew 929 plants. उन 929 प्लांट्स के लिए उसने ऑब्जर्व किया कि कितने पर्पल हैं, कितने वाइट हैं, और उसने टेस्ट स्टेटिस्टिक कंप्यूट कर ली. दिस इज कॉल्ड द ऑब्जर्व्ड टेस्ट स्टेटिस्टिक, and this is what Mendel's observed test statistic came out to be 0.00888805. उसको मैंने इस लाइन के इस ग्राफ के ऊपर प्लॉट कर दिया है. सो दिस रेड डॉटेड लाइन रिप्रेजेंट्स व्हाट? इट रिप्रेजेंट्स द स्टेटिस्टिक दैट मेंडल ऑब्जर्व्ड. अब हम इन स्टेप्स के ऊपर वापस आ जाते हैं. So first you come up with a statistic that helps you decide whether the data supports the model or an alternative view of the world. स्टेटिस्टिक आपने इस तरह सेलेक्ट करनी है कि हायर वैल्यूज ऑफ इट support the alternative. Then you simulate the statistic under the assumptions of the model, which we did. Then you draw a histogram of these simulated values. This is the model's prediction for how the output should come out to be. ये histogram भी आपने draw कर लिया. Then you compute the observed statistic from like the actual real sample that was used in the study. ये observed statistic हमारे पास पहले ही है. Then what you do is that you compare this value, this dotted line वाली value with your distribution, with your histogram, in order to decide whether your data is actually coming from the model or not. मतलब either you will support the model or you will not support the model. In terms of statistics, this translates to either you reject the null hypothesis or you fail to reject the null hypothesis. All right. So, however, the thing is कि अभी एक red line drawn है. From this line, how on earth do I know just by looking at this कि मैंने इस statistic को reject करना है या नहीं करना? So, in our lecture, the intuition that we look at and the intuition that we build on is कि you define a certain threshold, जिस तरह ये मेरी distribution है और मैं randomly define कर दूं कि ये जो 0.02 की value है, अगर इससे बड़ी है मेरी ऑब्जर्व्ड स्टेटिस्टिक तो मैं नल को रिजेक्ट कर दूंगी, अगर इससे छोटी है तो मैं नल को एक्सेप्ट कर लूंगी, या आई विल फेल टू रिजेक्ट द नल. तो दिस इज अ सर्टेन थ्रेशहोल्ड दैट यू डिफाइन as part of the design of your study. इसको आप इस तरह डिफाइन कर सकते हैं, जो अभी मैंने बनाई है इट इज़ अ डिस्ट्रीब्यूशन, मतलब इस हिस्टोग्राम के अंडर जो एरिया है it should sum up to 100%. It's a distribution. So, the thing is कि मैं इस तरह कर सकती हूँ कि I can say कि अगर इस हिस्टोग्राम की टेल के अंदर लाइक लास्ट 5% में वैल्यू आती है तो फिर रिजेक्ट कर दो नल को. अब 5% के अगेंस्ट मैं अगर लाइन ड्रॉ करूं एंड आई ड्रॉ अ लाइन एट 0.03 फॉर इंस्टेंस, तो इट वुड मीन कि इसके इस साइड पे जो है मेरा 5% एरिया है. लेट मी सी इफ आई, no, I didn't draw it over here, but I will quickly draw it over here for your information. Okay, this is terrible. What did I? Oh, that's what I did wrong. ठीक है, so if this was my histogram और मैं define कर दूं, मैंने set कर लिया है कि 10% and this is 10%. Suppose कि ये जो एरिया मैंने हाईलाइट किया है हिस्टोग्राम के नीचे जो 100% एरिया है उसमें से 10% इस हाईलाइटेड रीजन में है. डज दैट मेक सेंस? सो द थिंग इज कि ये जो एरिया मैंने डिफाइन किया है ये मैंने डिफाइन किया है एज पार्ट ऑफ माय स्टडी. सो दिस इज कॉल्ड अल्फा. Alpha is also basically called the significance level. ऑलराइट, सिग्निफिकेंस लेवल को हम अल्फा भी कहते हैं. सो ये सिग्निफिकेंस लेवल आप डिफाइन करते हैं. It's very easy to interpret as well actually. I mean it's exactly the way that it sounds. आपने कहा है कि कितना मेरा रिजल्ट सिग्निफिकेंट होना चाहिए. कितना सिग्निफिकेंट होगा तो मैं अपने नल को रिजेक्ट या फेल टू रिजेक्ट करूंगी. दिस इज व्हाट यू आर डिफाइनिंग. सो अगर मैं सिग्निफिकेंस लेवल को 10% सेट करूं तो इसका मतलब है कि ये लास्ट वाले 10% में अगर वैल्यू आई, या इसेंशियली इट मीन्स कि अब ये जो 10% सिग्निफिकेंस लेवल है इसके कॉरेस्पॉन्डिंग यहाँ पे कोई ना कोई वैल्यू तो बनती होगी ना, दिस वैल्यू, राइट. सो ये वाली जो वैल्यू बनती है, this is, I'm just gonna label this over here as well. These are some terminologies that are often confusing for students up until the very end. So I want to spend some time on this. This is the critical value. The critical value is just the value of the, can someone tell me कि ये x axis पे क्या था in fact? So guys, this is very simple. X axis पे तो टेस्ट स्टेटिस्टिक की values थी ना? Test statistic values on the x axis. So the critical value is the value of the test statistic that corresponds to your preset significance level. Does that make sense? Awesome. So, significance level आप खुद define करते हैं. Common levels that we define are 10%, 5%, 1%. And significance level जब आप define करते हैं तो उसके corresponding जो graph पे value आती है उसको हम critical value कहते हैं. So it means कि जो आपका observed statistic है अगर वो इस value critical value से ज़्यादा आता है, if it's on this side of the critical value, so it means that it is far from the center of your null, which means that you have a lot of evidence against your null, right? So, if your observed test statistic is greater than the critical value, then you reject the null hypothesis. Similarly, अगर वो इस side पे हो, if it's less than the critical value, then you fail to reject the null. Are there any questions up until now?
I
I
just want to
just
ask if we have the probabilities on the y-axis and test statistic on the x-axis. Also, you said that if the observed test statistic is after the critical value, we either reject the null hypothesis or we fail to reject the null hypothesis. So, do we like set this already? That for example, we have. This is the histogram for the null hypothesis. So उसका mean बताता है कि our observed statistic should be towards the right or the left, like
अच्छा मैं
the
आपको clarify करती हूँ. First, like your very first question, if I got it right, you wanted to understand कि इसके हर axis पे क्या होता है. The thing is बिस्मा कि हमने 10,000 trials run किए थे. हमारे पास 10,000 values थी test statistic की. उन 10,000 values को use करके हमने histogram बनाया है. Alright? इसीलिए हमारे पास test statistic जो है वो आपके पास है on the y-axis, and let me show you on the x-axis, and on the y-axis you have the number of trials जिनके लिए value इस bracket में इस bin में fall कर रही थी. Make sense?
oh,
This this
okay,
is
okay.
how this is how histograms work for distributions.
Oh, so
Second आपका क्या question था?
um I wanted to ask, acha, so basically we will for in order to draw a histogram, we need to take samples from 10, 20, and we need to exponentially increase our sample.
You need to have lots of samples in order to make a histogram. 1020 तो बहुत छोटा number है.
Yeah,
हमने
yeah,
अपना
yeah.
histogram 10,000 values का बनाया.
ठीक है, उससे हिस्टोग्राम बन गया तो उस हिस्टोग्राम का मीन बताता है कि हमारा नल हाइपोथेसिस का ऑब्जर्व स्टैटिस्टिक
नो
किधर
नो
होना चाहिए.
नो नो, ये हमने हिस्टोग्राम जो है ये हमने वैल्यूज को टेस्ट स्टेटिस्टिक के अंदर सिम्युलेट करके सिंथेटिकली जनरेट किया डेटा, राइट? ये तो
ओके.
हमने खुद जनरेट किया है. जो ऑब्जर्व स्टेटिस्टिक है जो रेड लाइन से इंडिकेटेड है वो किसी एक्चुअल सैंपल से रियल वर्ल्ड डेटा से आ रहा है. जैसे हमने मेंडल के मॉडल की assumptions के अंडर ये 10,000 सैंपल्स जनरेट करके ये हिस्टोग्राम खुद बनाया था.
ओके.
और
ओके.
मेंडल ने इन रियल लाइफ 929 प्लांट्स के लिए एक्चुअली ऑब्जर्व किया था उन्हें ग्रो करके या जिस तरह भी उन्हें ऑब्जर्व किया कि उनमें से कितने पर्पल फ्लावरिंग है कितने वाइट हैं और उसने एक्चुअल में टेस्ट स्टेटिस्टिक कैलकुलेट की. तो दैट इज द रेड लाइन, दैट्स द ऑब्जर्व्ड स्टेटिस्टिक.
Okay, okay, got it. So our observed statistic should be after the critical value.
नो नो, नॉट दैट इट शुड बी. देखिए ऑब्जर्व स्टेटिस्टिक आपकी जितनी नल के हिस्टोग्राम के सेंटर के करीब है उतने ज्यादा चांसेस हैं कि एक्चुअल वैल्यू जो है रियल वर्ल्ड वाली वो नल को फेवर कर रही है, राइट? और जितनी वो दूर है उतने चांसेस हैं कि वो नल को फेवर नहीं कर रही. सो क्रिटिकल वैल्यू जो है अगर उससे ज्यादा होती है वैल्यू, दिस इज बेसिकली लाइक अ थ्रेशहोल्ड, कि इस थ्रेशहोल्ड से अगर बड़ी वैल्यू ऑब्जर्व की है तो रिजेक्ट द नल, और इस थ्रेशहोल्ड से अगर छोटी वैल्यू ऑब्जर्व की है तो देन यू फेल टू रिजेक्ट द नल. मेक सेंस?
Yeah, it does. Okay, great.
परफेक्ट. सो इसके ऊपर हम वापस आ जाते हैं, एंड सपोज करें कि ये जो पिंक लाइन है ये ऑब्जर्व्ड वैल्यू बता रही है, ठीक है? द पिंक लाइन. सो अब ये ऑब्जर्व्ड की वैल्यू जो है ये क्रिटिकल वैल्यू से अगर तो है ऑन द right, if it's greater than the critical value then I will reject the null. It's in the rejection region. अगर ये उसके opposite side पे होती तो I would have failed to reject the null. Make sense? और ये क्रिटिकल वैल्यू डिफाइन हम इस तरह कर रहे हैं, क्रिटिकल वैल्यू आप प्रीसेट नहीं करते, आप सिग्निफिकेंस लेवल को प्रीसेट करते हैं. द सिग्निफिकेंस लेवल टेल्स यू व्हाट द क्रिटिकल वैल्यू इज गोना बी, because the significance value is just the area that you are defining, कि इतने परसेंट एरिया जो टेल पे है अगर उसके अंदर वैल्यू आ रही है ऑब्जर्व्ड तो ये रिजेक्शन रीजन है. द सिग्निफिकेंस लेवल टेल्स यू कि इस रीजन एंड ऑनवर्ड से रिजेक्ट कर देना है आपने. मेक सेंस? सो दिस येलो रीजन, सपोज अगर ये 10% होता, सो इट मीन्स कि येलो हाईलाइटेड एरिया में 10% एरिया आ रहा है ऑफ द हिस्टोग्राम अंडर द हिस्टोग्राम कर्व. So the green value, the critical value, is just the value that is corresponding to that 10%. All right. On that note, let's circle back to this graph. अभी तक मैंने कोई alpha define नहीं किया हुआ. And that takes me to one last very important terminology before we move on to questions as well, and that is p-value. P-value can be a little bit tricky, but as long as इससे पिछले concepts are clear to you, if you understand what the significance value, what the critical value, and what the observed statistic mean, so you're in a good position to understand what the p-value is. P-value means the observed significance level. This is the formal definition. It is the chance under the null. Under the null means assuming that the null is true. So the p-value is the chance under the null that the test statistic is equal to the value that was observed in the data, or is even further in the direction of the alternative. This is the formal definition of the p-value, and if I show you through the graph, it's even simpler. So ये जो मैंने स्टेटिस्टिक ऑब्जर्व की है, इस स्टेटिस्टिक के जो एरिया बनता है राइट पे अंडर द नल ग्राफ, that is the p-value, this area. So I'm just gonna highlight this over here as well. This is the p-value. That is why it's also called the observed test statistic. इसको लिख भी लेते हैं. P-value also called observed test statistic. इसीलिए हम इसको sorry, not observed test statistic. What did I do here? Observed significance level. So इसीलिए हम इसको observed significance level कहते हैं, क्योंकि actual significance level जो था वो आपने define किया था 10%, 15%, whatsoever. P value is the significance level that you actually observe, that tells you how significant your results are. एंड ये वाला एरिया है. इन दिस केस अगर सिग्निफिकेंस लेवल 10-15% है तो एविडेंटली इट शोज कि पी वैल्यू उससे छोटी ही आई है. So it means कि if the p-value is less than alpha, then you reject the null, which is kind of the same thing as saying that if the critical value, sorry, if the observed statistic is greater than the critical value. Does that make sense? Are there any questions? I'm actually going to pause on this graph for like a minute and I will let you guys go over this.
I am just confused between the observed test statistic and the observed significance level because it's like it has a very overlapping effect.
या अच्छा, जो टेस्ट स्टेटिस्टिक है वो हमारे पास एक्स एक्सिस पे टेस्ट स्टेटिस्टिक की वैल्यूज हैं, राइट? सो पिंक लाइन से इंडिकेट हुआ है कि ये एक्स एक्सिस पे जो वैल्यू आती है टेस्ट स्टेटिस्टिक की, वो ऑब्जर्व स्टेटिस्टिक है, जैसे हमने यहाँ पे ये मेंडल वाली रेड लाइन से प्लॉट की थी। अब इस रेड लाइन के इस साइड पे जितना एरिया होगा अंडर दिस हिस्टोग्राम वो पी वैल्यू होगी। मेक सेंस? सो ये पी वैल्यू ये हाईलाइटेड एरिया है।
So is it the same thing then?
नो नो, नॉट एट ऑल।
Um, oh, okay, okay. So test statistic is the line. It is the particular like a value on the
Yeah,
x-axis,
exactly.
and then p-value is actually the area after that line.
Absolutely, you
Oh,
got it
okay, okay,
completely right.
okay, okay, okay. So we'll compare the area to the significance level.
हाँ एग्जैक्टली, आप इस ऑब्जर्व सिग्निफिकेंस लेवल को सिग्निफिकेंस लेवल से कंपेयर कर सकते हैं, मतलब पी वैल्यू को अल्फा से कंपेयर कर सकते हैं, या फिर आप क्रिटिकल वैल्यू को ऑब्जर्व टेस्ट स्टेटिस्टिक से कंपेयर कर सकते हैं। इसेंशियली एक ही बात है इनका कंपैरिजन।
Okay, okay, got it, got it.
आई विल स्टिल गिव इट लाइक अ फ्यू मोर सेकंड्स, स्टिल गो ओवर दिस। आई वांट कि ये चीजें एब्जॉर्ब हो जाएं, दिस इज रियली इम्पोर्टेंट। Okay, are there any questions before we move forward? Awesome. We're gonna move on then. So इसके लिए अगर हमने p वैल्यू को कंप्यूट करना है, तो हम अपने डेटा को यूज करके सिंपली कंप्यूट कर रहे हैं। इन एक्चुअल हमें पता है कि इस रेड लाइन से आगे जितना एरिया है अंडर दिस हिस्टोग्राम, वो p वैल्यू होगी। अगर मैंने कंप्यूट करनी है p वैल्यू, तो मेरे लिए बहुत सिंपल है। व्हाट आई विल डू इज कि मैं देखूंगी कि मेरे ये जो 10,500 सैंपल्स थे, इनमें से कितने सैंपल्स ऐसे थे जिनमें द वैल्यू वाज ग्रेटर देन और इक्वल टू द ऑब्जर्व्ड स्टेटिस्टिक, एंड देन आई डिवाइड दैट विद द टोटल नंबर ऑफ सैंपल्स विच वाज 10,000। सो यहाँ पे मैंने उसको इस तरह कंप्यूट किया है इनफैक्ट। See, sample starts greater than or equal to observed statistic divided by repetitions. So this is what my p-value comes out to be. 54%, 54.06% is a very high p-value in fact. This is what I've written down on a concluding note. Okay, if the significance level is set at 10%, for instance, then you will fail to reject the null hypothesis based on the observed test statistic. Because 10% का जो significance level है, p value उससे काफी बड़ी है। मुझे critical value नहीं पता, क्योंकि मैंने ये observed statistic को अगर मैं यहाँ पे plot करती, तो फिर उसके corresponding जो value आती वो critical value होती। Are there any questions before we move further?
No, it's clear.
Awesome. We're gonna look at two important questions. Hold on a second. Okay, इसमें से कुछ एरिया एक आपके past एग्जाम से भी है, I suppose, and कुछ I want to iterate these through a question now. And for those of you watching, you should definitely pause and try this out on your own as well. For those of you here, I will pause and give you guys some time to go through this too. So, a study evaluates the effect of a new sleep enhancing therapy to improve sleep quality in adults. The null hypothesis states that, well, ये actually अगर आपको हम लिखने को कहें null or alternative, तो you should be able to do that as well. The null means no effect. So the null hypothesis means states that the new sleep therapy has no effect on sleep quality. The alternative states that the new sleep therapy improves sleep quality. इसको लिखने का और ये भी तरीका है that the mean sleep quality index of adults receiving the therapy is the same as the general population. Alternatively, alternative hypothesis here, the mean sleep quality index of adults receiving the therapy is higher than the general population mean. So, this really means कि आप null और alternative को several ways में लिख सकते हैं very often. With that, let's look at this. We are given two distributions instead of just one for this question. You can assume के data हमने generate किया whatsoever. Either way, doesn't matter to us. जो blue वाला curve है, that is data that you have generated under the null hypothesis. जो red line वाला curve है, that indicates the data that you have generated under the alternative hypothesis. इसके ऊपर critical value भी plotted है. The critical value is 58.22. Similarly, you are given this table of values as well. So I will just pause over here for about a minute and I want you to just look at this table, identify what these values are representing. ये जो आपको probabilities वगैरह दी हुई हैं table में, and look at the curves and understand them well. Then we will look at the questions. Okay, are there any questions? Okay, since there are no questions, तो अब हम अपने ये वाले questions देखते हैं. First, what is the significance level alpha? Okay. Um, I do have, I think, one or two people in the meeting still. So if one of you could tell me too, what is alpha? What is the significance level? The answer is given to you in the table. No one. All right. So what you're doing is कि इधर इसको देख लेते हैं. Let's recall once as well, in fact. Significance level जो है वो area है under the null curve that is towards the right of the critical value, right? और हमें इस केस में पता है कि critical value हमारी 58 है. So ये जो green में चीज highlighted है, this is alpha in fact, because this is the area under the null blue curve where the value is greater than the critical value. So इस टेबल में से अगर हम देखें एक्चुअली तो ये वैल्यू 0.05 बनती है. Probability that x is greater than 58, which was the critical value under the null hypothesis, 0.05. So this is gonna come out to be 5% or 0.05. Are there any questions? Okay. Next, you are required to calculate the p-value if the observed test statistic is 60. So we're told कि observed statistic 60 है और p-value आपने calculate करनी है. Again, I will pause over here for a few seconds.
Will it be 0.03?
Perfect, excellent. That's what I was looking for. It will be 0.03 because let's quickly recall looking at this कि p value जो है वो observed test statistic के right पे जो area है under the null वो होता है. So मैंने अपनी observed statistic इसके ऊपर plot तो नहीं की हुई, but if you had to plot it, this is where it would be. और इसके right पे area होता under the null, which would be this area basically. So ये आपको given है as 0.03. Are there any questions? No questions. So 3% or 0.03. So would you reject the null or not? I will pause over here for a few seconds. इसको देख लें. Would you reject the null or not? Observed statistic 60 है, critical value 58 है, significance level is 5%, and the p value is 3%.
Um,
Yes?
our p-value is less than the significance level, so I think we will.
Yeah, you should be more
Yeah.
confident in your answer. आप ठीक कह रही हैं. You will reject the null. इसकी दो possible explanations दी जा सकती हैं और दोनों valid हैं. Since the p value जो आपने explanation दी is less than alpha, which is the significance level, ठीक है? Or you could also say that the observed test statistic is greater than the critical value. So ये दोनों explanations valid हैं in fact. Okay, are there any questions? Great. अगर इसका opposite होता तो हम fail to reject the null लिखते. So for the very last part of this question, you have to estimate the power of this study. But power is something that I have not iterated as yet. So I will quickly walk you over power as well. Before I walk you over power, in fact, I just want to help you recall two different types of errors. Yeah, ये देखें, ये वाला table है. I'm quickly gonna reiterate this. What happens is that in actual life, either the null is true or the alternative is true, right? And one of the two things that you will do is that either you will reject the null or you will not reject the null. This doesn't mean that you're gonna be right every single time. Just like एक आपके पास ML model है जिसने कोई binary classification का task करना है. So either the model will correctly predict the positive class or it will correctly predict the negative class, or the other two possibilities are that it falsely predicts the positive class or it falsely predicts the negative class, which are false positives and false negatives respectively. तो इसमें भी इसी तरह होता है. Sometimes you can reject the null even though the null is true. All right, in which case you are doing a type 1 error. This is a type 1 error. It's also a false, sorry, it's also a false positive. Alternatively, आप ऐसा भी कर सकते थे that the alternative is true but your test doesn't reject the null, in which case you do a type 2 error. So this is exactly what's stated over here as well. Type 1 error means rejecting a true null hypothesis. Type 2 error means failing to reject the null when it is actually false. So I'm going to pause over here for 1 minute on account of the azan, and you can just go over this particular slide in the meantime. Okay, all right. So to quickly reiterate, a type 1 error corresponds to rejecting a true null hypothesis, and a type 2 error corresponds to failing to reject the null when the alternative is true. पहले हम type 1 को देख लेते हैं. On your graph, you should be able to आइडेंटिफाई, जिस तरह हमने अंडरस्टैंड किया है बाकी सब एरियाज को, बाकी सब वैल्यूज को, उसी तरह आपको टाइप 1 एंड टाइप 2 एरर की प्रोबेबिलिटीज को भी आइडेंटिफाई करना आना चाहिए. सो अ टाइप 1 एरर मींस कि मैं रिजेक्ट कर रही हूँ नल को. व्हाई डोंट आई जस्ट कॉपी दिस हियर? इन फैक्ट, व्हाई डोंट आई जस्ट राइट दिस डाउन हियर? Rejecting the null falsely when it is actually true. What is the probability of this happening? So अभी मैं null hypothesis के अंडर हूँ. Where is the area in which I reject the null? कौन से एरिया में मेरी वैल्यू आती है तो मैं नल को रिजेक्ट करती हूँ? इन एक्चुअल ये जो ग्रीन लाइन है क्रिटिकल वैल्यू, इससे ज्यादा अगर मेरी वैल्यू आए तो मैं नल को रिजेक्ट कर देती हूँ, राइट? सो जो इसके अंडर एरिया है ओवर हियर, ये जो हाईलाइटेड एरिया है, what percent was this area?
0.05.
Yeah, correct. Thank you. This was 5%, 0.05. So इस एरिया में अगर वैल्यू आती है तो मैं उस वैल्यू को रिजेक्ट कर देती हूँ. जो एरिया मैंने हाईलाइट किया है, एक्चुअली यू नो व्हाट, इन रियल लाइफ इस एरिया से आगे भी जो वैल्यू आती है वो भी रिजेक्ट हो जाती है. अगर नल कर्व यहाँ पे खत्म हो जाते हैं और मेरी वैल्यू यहाँ पे जाके आती है तो भी आई एम गोना रिजेक्ट द नल, राइट? लेकिन जो मैंने एरिया हाईलाइट किया है, दैट इज द एरिया अंडर द नल where I am rejecting the null. So the probability that my value under the null falls in this range is 5%. So जो type 1 error की probability है in this case, वो exactly 5% है in fact. So type 1 error की probability we can conclude के होती है significance level या alpha के equal. Does that make sense? Are there any questions? So identifying this area of type 1 error is actually fairly straightforward still. With that, let's move on towards the type 2 error. And let's quickly recall कि type 2 error था क्या? Failing to reject the null when it is actually false. मतलब reject आपने करना था लेकिन reject आपने किया नहीं उसको. So let me just write this down as well. I'm actually still building towards power. So failing to reject the null when it is actually false, या the alternative is true. अब हमने इसकी probability भी calculate करनी है. In fact, we haven't reached this one yet. हम actually इस graph को use करके, okay, perhaps we could calculate it. So, failing to reject the null falsely when it is true. Failing to reject the null when it is true. Falsely की जरूरत नहीं है यहाँ पे भी. Okay, what is the area in which you fail to reject the null? This is very straightforward. हमने डिस्कस किया था कि अगर ये वाली जो ग्रीन लाइन है क्रिटिकल वैल्यू, इसके लेफ्ट के ऊपर वैल्यू आए तो यू फेल टू रिजेक्ट द नल, करेक्ट? अगर इसके लेफ्ट के ऊपर वैल्यू आती है तो आई कैन लुक एट द एरिया अंडर द ऑल्टरनेटिव कर्व, विच एसेंशियली मीन्स कि ये वाला एरिया.
0.95.
Hold on, I haven't gotten there yet. Um, okay, पहले हम एरिया हाईलाइट कर लेते हैं. I will double check the value as well. Not sure, to be honest. I will have to check. So ये जो येलो में एरिया हाईलाइटेड है, ये एरिया रिप्रेजेंट कर रहा है the probability of a type 2 error happening. क्योंकि ये वो एरिया है जिसमें आई फेल टू रिजेक्ट द नल. एंड लेट्स नोट, एक कॉमन मिस्टेक ये है कि स्टूडेंट्स ब्लू कर्व के अंदर के एरिया को देख सकते हैं. हालांकि द ब्लू कर्व एज्यूम्स दैट द नल इज ट्रू, हमने एज्यूम करना है कि ऑल्टरनेटिव ट्रू था और फिर भी यू फेल्ड टू रिजेक्ट द नल. सो ये जो येलो हाइलाइटेड एरिया है, दिस रिप्रेजेंट्स द प्रोबेबिलिटी ऑफ अ टाइप 2 एरर, because this is the area under the alternative curve in which you are failing to reject the null. So let's see. Yeah, the probability that x is less than this critical value under the alternative. So under the alternative, the probability that x is less than the critical value is actually 0.85. Did you say 85 or did you say 95?
No, I said 9.5, but now I get it why it's
Okay,
8.5.
all right. Are you sure you get it?
Yeah, because
ठीक
it's
है.
not the null graph that we will
Yeah,
check.
absolutely. This is actually a very common mistake as well. जो टाइप 2 एरर है वो एज्यूम करता है कि ऑल्टरनेटिव ट्रू था, टाइप 1 एरर एज्यूम करता है कि नल ट्रू था. तो ये जो प्रोबेबिलिटी है ये एक्चुअली 85% है. मैं यहाँ पे स्पेसिफाई भी कर देती हूँ. अंडर द ऑल्टरनेटिव x is less than the critical value. Now what have I tried to build to over here? अब हम statistical power की बात करेंगे. So I will quickly iterate this over here. So statistical power is simply the power to avoid a type 2 error. It is the power to avoid a type 2 error, which simply means कि ये जो probability of type 2 error है, the statistical power is simply equal to 1 minus this. So it's very simple. Once you understand the concept of a type 2 error, then it's really straightforward. यहाँ पे लिख लेते हैं. Power is equal to 1 minus the probability of a type 2 error. And since हमने calculate कर लिया है, देख लिया हमने कि type 2 error की जो probability है, that is actually equal to 85%. So this means that your power will come out to be what? 15%, which is a very low level of power actually. But are there any questions so far? Okay, logically, what could I do to increase this power? Um, ये जो null और alternative के curves हैं, this is something for you to think about as well. I will not go over all of this content from the lecture. इन कर्व्स के बीच में ये जो डिस्टेंस है, अभी ये कर्व्स बहुत क्लोज हैं टू ईच अदर. अगर ऑल्टरनेटिव के कर्व को उठा के मैं यहाँ पे रख देती तो ये एरिया कम हो जाता, राइट? सो दिस मीन्स कि जितना ज्यादा डिस्टेंस होता है बिटवीन द नल एंड द ऑल्टरनेटिव कर्व उतनी ज्यादा पावर होती है. ये डिस्टेंस हम इस तरह डिफाइन करते हैं, the center of the null से लेके the center of the alternative तक. This distance actually represents the effect size, which is one of the main ingredients of power over here. So ये effect size है. जितना ज़्यादा effect होता है, effect size is actually in simple words it corresponds to कितना effect था उस treatment का on the outcome. So जितना ज़्यादा effect होगा उतनी ज़्यादा statistical power होगी आपके पास. The effect size is something that you can't practically influence. For instance, if you're observing कि एक certain pill का एक disease पे कितना impact है, तो आप उसका impact जबरदस्ती नहीं बढ़ा सकते. You can measure कि कितना effect size था, कितना impact था, but you can't enforce it. One other thing is sample size. अगर आप sample size को increase करें तो ये curves आपके और narrow हो जाते हैं. And the narrower that these curves are, the lesser area is gonna fall over here. And in turn, your power is gonna increase. So sample size increase करने से भी power increase होती है. Um, and then there is the variance. I will let you go over the rest of power yourself as well. But are there any questions before we move on, though? I will just write this down over here. Are there any questions?
No.
Okay, all right, perfect. So, this is the last question that I have for today. Um, One question from bootstrap sampling from a past exam to iterate just a couple of small things. So, you are investigating whether background music negatively affects exam performance or not. To assess this, you conducted an observational study by analyzing the exam scores of two groups of five students with similar characteristics. One group studied with background music, this is your treatment group, and then the other group studied without background music, this is your control group. Each exam score is out of 100 और आपको ये scores given है for the treatment and the control groups. To validate your hypothesis, you conducted a bootstrap analysis. What exactly is bootstrap sampling? बूटस्ट्रैप में आप ऐसा करते हैं कि आप अपने सैंपल के अंदर से रीसैंपल करते हैं with replacement. You do that in order to increase your data because sometimes mazid samples nikalne from nature is difficult for you. Sometimes it's infeasible altogether. Sometimes it's not possible. Sometimes it's just too expensive. However, bootstrap sampling के लिए important ये होना चाहिए कि आपका जो original sample है क्योंकि आप उसी में से resample की जा रहे हैं several times. So your original sample itself must be well, it must not be biased, it must be well representative of the population, and your original sample must be large enough. अगर ओरिजिनल सैंपल सिर्फ 5 या 10 का हो तो उसमें से आप जितने मर्जी रीसैंपल्स निकाल लें इट शुडंट रियली मैटर राइट बट अगर ओरिजिनल सैंपल मेरे पास 10,000 का है तो देन माई रीसैम्पलिंग वुड मेक सेंस टू मी because I'm trying to increase my data. The second thing is कि जितने ज़्यादा आप samples निकालें जितने ज़्यादा दफ़ा आप resample करें वो आप with replacement करते हैं which means कि repetition तो हो सकती है बट उसका साइज ओरिजिनल सैंपल के साथ सेम ही होता है सो इस ट्रीटमेंट ग्रुप की ये जो 5 नंबर्स हैं इनमें से अगर मैं एक बूटस्ट्रैप सैंपल जनरेट करूं तो इट इज पॉसिबल दैट द सैंपल कुड लुक लाइक दिस ऑलराइट सो इसमें कुछ नंबर्स जैसे रिपीटेड हैं बट साइज इसका एग्जैक्टली ओरिजिनल सैंपल जितना ही है सो एनीवे दिस इज व्हाट आई हैव obtained. मैंने 3 times bootstrap samples लिए I took 3 bootstrap samples और उन 3 में ये numbers आए मेरे पास हर sample के लिए मैंने mean भी compute कर लिया I did the same for the treatment group and for the control group. So before we look at the rest, state the null and the alternative hypothesis for this experiment. I will pause over here for a few seconds and I want you to think about this. Okay, so what is the null? What is the alternative? Okay, so it's really simple. अगर आप investigate कर रहे हैं background music का effect on exam performance, तो null assumes no effect, which means that the null is that background music does not affect exam performance. The alternative is that background music आप in this case in fact negative impact measure कर रहे हैं so you would say that negatively impacts exam performance in which case null ये भी हो सकता था that it does not impact exam performance or it positively impacts exam performance so this really depends on your question even if you wrote down that the null is k the background music has no impact on exam performance and the alternative is that it does have an impact on exam performance that would still have been acceptable I suppose so हमने sample means calculate किए हैं original and treatment groups के I've already written these down over here because it's simple enough to compute in 5 numbers का mean क्या आता है next, which of the two test statistics, T statistic and Z statistic, is more appropriate for testing your null hypothesis? Justify your answer. So these are different tests that you have looked at, t test, permutation test and z test. और इसमें से detailed course में हमने सिर्फ permutation test की cover की है. But for the sake of one example, you can see over here कि permutation test की कोई assumption नहीं है, t and z tests की assumptions हैं. The important thing to note over here is कि t test wants a small sample size and z test के लिए the sample size has to be large. In our case हमारा sample size 5 है, which is very small, which is why we're choosing a t stat. Lastly, a colleague suggests that the variance of the sample means for both groups appears too high. She proposes increasing the size of each bootstrap sample to address this issue. Do you agree with her approach? Provide proper reasoning for your answer. We do not agree with her approach because, like I mentioned at the very beginning, this is a trick question. Bootstrap sampling के अंदर you have to ensure that the size of every resample is the same as the size of your original sample. तो आप size increase ही नहीं कर सकते. अगर आप size increase करें भी तो भी you are still sampling from those same 5 values, so it shouldn't make any difference. That's actually gonna be it from my side for today. Are there any questions?
No.
Okay, all right, perfect, guys. All the best with your exam too. Allah Hafiz.